when it's hot outside. And remember that on Monday, which I only vaguely remember, I had not had enough caffeine, and I sort of remember lecturing and talking to you guys, but I also don't, which is that's a whole other issue. When it's hot, okay, when it's hot, you have competition for blood flow between your muscles and your skin. Okay. As blood goes to the skin, that's going to decrease venous return. Okay. You guys did really well on the test. On one of the ways that we increase venous return with exercise, the muscle pump. As blood goes towards the skin, there's less of it in the veins around the muscles. And so even though we're exercising, we're going to get less muscle pump and less venous return. Because there's less venous return, stroke volume either will not increase as much as it should, okay, or in some instances it will fall. To counteract that, heart rate must increase to maintain cardiac output. Okay. So when we look at exercise in a hot versus a cold environment, right? Here's heart rate, here's exercise time or exercise intensity. You can really be either one. Heart rate tends to be higher, okay, in hot environments at any given work rate at any given duration than in a cool environment. Correspondingly, VO2 tends to also be higher. You expend more energy when you're exercising in the heat, partially because sweating and having an increased core body temperature through something called the Q10 effect also tends to raise metabolism. Okay, so VO2 is going to be a little bit higher. Well, lactate levels, because VO2 is higher, lactate tends to be a little bit higher. Okay, all of this illustrates something that I'm going to write on the board. Okay, that is really, really important to understand about exercising when it's hot out, because it will play a very key role in some of the things that you guys found trying to counteract. Okay, there is a phenomenon that is called cardiovascular drift. Okay, cardiovascular drift. This heart rate increasing over time, okay, potentially at the same work rate, increasing over time. Heart rate is drifting upwards. Okay, so cardiovascular drift leads to a couple of things. During a bout of exercise, as you experience cardiovascular drift, in real time, your VO2 max drops. Okay, you start off a bout of exercise and your VO2 max is 50 mLs per kg per minute. It's hot outside. Irony, it's like the coldest day we've had so far, right? But it's hot out. And a half an hour into that bout of exercise, your VO2 max is not 50 mLs per kg per minute anymore. Your VO2 max is now 44 or 45. Okay. As blood goes to the skin, and as we lose plasma via sweating, okay, the skin, as it goes there, we have a decrease in venous return, right, which leads to a decrease in preload, which leads to a decrease in stroke volume. Remember, stroke volume is one of the best predictors of VO2 max. So max stroke volume falls. As we lose plasma from our blood via sweating, okay, that is going to decrease our blood volume, which also decreases venous return, decreases preload, and decreases stroke volume. Okay. So a half an hour into a bout of exercise in the heat, you are 10 or 15% less fit than you were when you started. And so now, right, I'll ask this again. We'll see if we can make sorry you proud. Those of you in endurance training class, or anybody who remembers, if anybody's in Christina's personal training class, I heard y'all had a pop quiz yesterday. You were in there, right? What is one of the things that we use most commonly to prescribe aerobic exercise or monitor exercise intensity while a person is going? Heart rate. Okay. If you are using heart rate, you will notice that your heart rate is drifting up. So you've got to slow down in order to keep your heart rate where it is. You have to slow down because as your heart rate goes up, right, you're now at a higher percentage of your new VO2 max. And so when it's hot out and you exercise and the day before you ran at 6 miles an hour and you felt fine and it's 100 degrees and 90% humidity today, that same 6 miles an hour and you feel like shit, that's a real physiological phenomenon, right? You are less fit once you start exercising and it's really hot out, okay? So functionally, you're less fit. It's different mechanistically, but it's kind of like going to altitude, okay? It's kind of like going to altitude. That by the simple fact that it's hot, you're already less fit, okay? So that's going to be a thing that's going to go on, all right? This is going to lead to decreased performance when it's hot out and we exercise in the heat, okay? So one of the consequences of exercising in the heat, right, if you can push through this lowered capacity, is going to be things like heat cramps or heat exhaustion or heat strokes, or there are these disorders that are going to happen if you do too much when it's hot, okay? Some of you, or many of you, if you played any sports or done anything, have probably experienced something like this, okay? Heat cramps, you just get cramps, likely due to a disruption of fluid and electrolyte balance. If anybody tells you that they know what causes cramps, we don't, okay? We don't. It's a little bit different in everybody. Is eating a banana going to solve your cramps? No, probably not in that particular way. We know the best way to treat cramps. They're associated with dehydration. They are definitely associated more so with dehydration in combination for dehydration from sweating, when you lose electrolytes. We treat them with fluids, or especially with like saline solution and those things, right? You get a bag of saline, right? They hook you up. I see people going at halftime of football games or soccer matches or basketball games, and they give them a bag of saline. You'll feel a lot better because your blood volume immediately goes right back up. Okay. Heat exhaustion is worse. Okay. You've got dizziness, sometimes vomiting, fainting, cold and clammy, or hot and dry. It just kind of depends. You tend to have lowered blood pressure and a elevated heart rate. Again, it's due to dehydration. As blood volume falls, blood pressure also falls. Okay. This is worsened in, you don't have to put your hands up. Anybody have POTS? Anybody? My wife has POTS. It's become much more common after we've all had COVID 7 times as parts of these sorts of things. But if you have what we call vasovagal withdrawal, where you cannot match the proper sympathetic and parasympathetic input to maintain blood pressure and things, that tends to get worse. My wife is going to go do a half marathon in Tulsa on Sunday. We have to have a whole protocol for what we do post race. If she stopped and went and got in the shower like right afterwards, she's going to pass out, right? Because she can't control blood pressure. And it looks like heat exhaustion is worse in the heat with some of these things. Regulatory mechanisms cannot dissipate heat fast enough, okay? And so we end up with inadequate blood supply to the skin. I did not tell you guys this on Monday, but we do have a problem with our thermoregulatory systems, okay? And that problem is when this begins to happen, okay? When push comes to shove, if you are motivated enough to continue exercising, you will begin to send blood away from your skin and send it back to skeletal muscle at very, very high exercise intensities if you're super motivated. It seems like a flaw in our evolutionary systems, but you can do it. At the end of the day, fight or flight in that way will win. But when you get to that point, as you stop going to the skin, you begin to lose your primary way of losing heat. And when you get into that zone, when that begins to happen, and we can get heat exhaustion and heat strokes really, really quickly. Okay. Why that's the case, we don't really understand. We don't really know, but it is a thing. Okay. So we've got to be really, really careful of all of that, especially in athletes and people that are really highly motivated to perform in certain circumstances. Okay. So the worst of our heat disorders is a heat stroke. Typically occurs when internal body temperature clears 40 degrees Celsius. Oftentimes it's up into the 41 or thereabouts. And what happens for a person having a heat stroke is their entire regulatory mechanism shut down in the hypothalamus. And things get flipped around, and they do not sweat. They do not send blood to their skin in those ways. And so very, very quickly, they can get into a really, it gets to here, you're in trouble, then, right, everything gets sort of shunted back inside, and we get this rapid increase. You have high rapid pulse, but you're hot and dry on the skin, rather than cool and clammy, you're not sweating. Breathing increases, you actually get hypertension, right? Where sympathetic nervous system is big response. You become unconscious, you become confused, and these kinds of things. This is the one that leads to death. This is the one that you've got to get people cooled off really, really quickly. And every year in the fall, right, in August, there will be football players that will die from heat strokes, right, because of all of this. They're not monitoring their temperatures. They've got, right, as you will see, you've got pads, you've got all of these things on. We also will talk about that if you take an energy drink and you take some kind of a stimulant, it makes it worse. And especially in individuals that have larger weight to body surface area ratios, offensive, defensive linemen, people that are larger, okay, in that way, their body surface area is widely related to your ability to dissipate heat, but we don't get a corresponding increase in surface area as our weight goes up as much as we need. And so folks that are like that, higher weight, are going to be at even more risk. Okay. Typically, the way we treat these things is to put people into ice baths, to pack them with ice, and we've got to get core body temperature down. It exceeds, right, about 42 degrees Celsius or somewhere in that range. We have limits for basically you've got neuronal death and things in the brain on all of this. Okay, Valerie.
School pharmacy, and we actually have saline like in the refrigerator for these kind of moments.
Hmm.
So it's like already like really cold.
So they'll give them an IV with cold water, basically. I can't imagine what that would feel like in a sort of normal conscious person, right? Like just think we're circulating like cold stuff through. Really, really important though, in that particular way for them to be able to do that. Okay. So you've got to pay attention to the warning signs. If you're ever around people and you've been doing stuff and it's hot outside, realistically, more heat illnesses occur in the mid 80s with high humidity than we get in super hot environments because people don't think the thermal stress is that much. And that's when they don't rehydrate properly. The single biggest thing to prevent loss and cardiovascular drift and to maintain performance and to prevent heat illness is hydration, 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 hydration. Okay. And when you start feeling bad, fucking stop. Okay. But hydration and hydration afterwards is really, really important. Okay. I talked about that. The big thing is, right, drinking plenty of fluids, schedule practices or events in the early morning or at night when it's not quite as hot. Wear light colored, lightweight, loosely woven clothing. For those of you that were finding things that like, here is this shirt. It's a thermo shirt. Were they light colored? Were they loose fitting? And those kinds of things. Most of them didn't look like they were. Fascinating types of questions in the midst of all of this. Okay. And then know the symptoms, right? You've got to know the symptoms. If you're ever out and it's been hot and people are doing things and they show the merest sign of confusion or discombobulation or forgetfulness or anything, get them to the hospital immediately. Okay, get them to the hospital immediately. That's gonna be the big sort of thing. Okay, well, we'll finish up by talking about an idea called acclimatization. Okay, acclimatization is physiological adaptations that occur that improve your ability to exercise and do work in hot environments. Not gonna lie, this is probably the oldest and most widely studied originally thing that began exercise physiology as a discipline. Okay. I think I mentioned the Harvard fatigue lab way back in like the first day of class, but the original exercise physiology lab was founded in the business school at Harvard in 1927, and they were founded to study factory working conditions. There was no air conditioning. There was no OSHA. Be careful what we vote for. We may be going back to that. It's my only political commentary for now. On a lot of different things, okay? We say we don't want regulations, but working conditions, all of that stuff, that was how, it was not done out of being nice. It was, how can we get more productivity from our people working these long hours in these terrible conditions? Okay? And so they studied heat acclimatization. What changes? When we put you in a hot environment for prolonged periods of time, when we put you in a hot environment and have you do just walk around, okay? You adapt over the course of a couple of weeks to reset the core temperature at which sweating occurs. It's normally 37.3, it goes down to like 37.2 or 37.1. If you've got a friend who exercises a lot outside and it's in the summer and those things, and you put them inside, they're gonna sweat like immediately on things, okay? We may not think of that as a particularly sort of positive adaptation in our everyday lives, but it's really, really good when you exercise and it's hot, because you're gonna start doing things, okay? That leads to keeping core and skin temps down, okay? Plasma volume increases. That's the other big thing that drives this. We reset the hypothalamus and you get more plasma volume. Having more plasma volume means when I lose stuff to the skin, when I lose stuff via sweating, heart rate doesn't fall quite as much. Okay? Doesn't fall quite as much. You may add a liter of plasma volume. Okay? You got a blood volume of 5 liters, it may go to 6. Okay? If you are going to have to exercise and do a race, love for that race to be in a cool or thermoneutral environment. But one of the other ways to train and to get better is to go heat acclimatize yourself and expand your plasma volume. And then take this increased plasma volume and increased blood volume and go exercise in a place where it's cool. Because then you don't lose it from sweating, but you keep it to increase venous return, to increase stroke volume. It takes about 10 days of 1 to 2 hours of daily activity in a hot environment. Only has to be walking, right? Modest intensity, 35 to 50% of VO2 max. So when it's the summer, just go outside for an hour and walk around. Okay? Just go outside and walk around. You will become acclimatized. Now, this goes away relatively quickly, but if you've got it and then you continue to exercise outside a little bit when it's hot, you'll keep a lot of it. You'll keep a lot of it around. Okay? Right. Why does sweat rate change? We just reset. Basically, we reset the hypothalamus. Because we're going to get more skin blood flow and sweating earlier, that decreases skin temp. Decreasing skin temp, more evaporation. These things keep core temp down, right? And then having more plasma volume means less effect of the drift. And so we're going to keep heart rate down. Some these are some old data that were republished in a thing in 1988. I'm showing you guys this. I should say this slide itself is about 25 years old. When I was a graduate student, we had a class on environmental physiology, altitude, heat, cold, those types of things. I'm sorry for all of you. We will have both an undergraduate and a graduate class in this here within a couple of years. We think it's really important. We've just not had the staff. We will soon have the staff to do this. But here is rectal core body temperature, right? Over 4 hours of exercise outside. Here we have an acclimatized person. Here we have the unacclimatized person, lower core temp. Here's heart rate in those same people, right? Heart rate stays down. Sweat rate is higher, okay? Sweating starts sooner, you sweat a little bit higher in the midst of this. So this is just some of the earlier data. This recreated it is actually from the 1970s on kind of what all is happening, okay? I want to show this as well because what we're seeing here is the sweat rate, and then we're seeing the core body temperature at which sweating begins. The cool thing about this is, and this is going to seem a little backwards to you guys, is that we sweat sooner. You sweat at a lower core body temperature, but the rate of sweating, the slopes of these lines are pretty much similar. So we don't really change anything about your sweat glands or anything else. You just change the set point in the hypothalamus about when onset is going to occur. And that's a really, really powerful adaptation for us. Okay. Okay. So we do this, we did that. Okay, great. That's acclimatization. That's exercise in the heat. Okay.